Hello, testing, testing. Hello, everybody. Just so you know, we are streaming live on YouTube. Don't do anything too embarrassing. Also, I wanted to show you guys this. We made the paper. This is the Lehi Free Press. They have done a nice article on us, and that's pretty cool. So congratulations, guys. Let's see, what else we got? We're gonna do a little more socializing for a bit. Wait for everybody else to, no, not that, to trickle in. But I need to put the Discord link together real quick. Hang on. Please make sure you have a name tag. We'll be starting in about 15 minutes. All right. Thank you all for coming. Good to see everybody tonight. I'm Thomas. I'm the president of the Game Dev Club. And up here on the slide, you can see a link to our Discord server. If you want to join our Discord server, please use that link. We do not give out public links, so please get that and ask me afterwards if you need access to this. And I think we're going to start a little early, so let's go ahead and go around and do introductions. So as you introduce yourself, please give your name, let us know what you do, and what your current project is. So I'm Thomas. I am a software engineer and freelancer. I do virtual reality app development and build tools, and I am currently working on Junksteroid, a Tetris Match 3 hybrid that's very fast-paced and has a retro 90s aesthetic. Let's go ahead and pass this around. Ben?
Hey, I'm Ben Cloward. I work for Unity, and I'm going to introduce myself in my talk, so I'll skip that this time.
Hi, I'm Matt. I'm a scientist. My current project is a co-op airship crew-based game where you go around and you have to do different things in your ship to protect it from during a skirmish, and you got to repair the mechs to get them back in the air. So,
I'm Ken. By day, I run a small software company that does VR design tools in Unreal Engine. My current side project is a game called Dirty Dirty Pirates. We just released it a couple of weeks ago. It's a local multiplayer, brutal, violent game.
Hey, I'm Matt. I'm a VP of product for a language learning company, and I run another meetup group that I won't cross-promote here. But I'm also in my spare time working on porting one of our games to Steam right now, cooking/horror game, and working on a mobile game.
I'm Laren Mortensen. This is my brother, Lauren Mortensen. We're both software engineers. Sorry to introduce them for you. I mean, so yeah, so we're interchangeable. So we're both software engineers, and we're working on Commander's Fury. It's basically a 3D Starfleet battle game, and basically we're excited we're going to try to launch this year.
Hey, I'm Garrett. I'm a software engineer. I'm between jobs right now. My game dev project is a cooperative RPG with a turn-based real-time hybrid battle system and a job system. And yeah.
I'm Taylor. I'm a electrical engineer by day and game dev by night. But I've been working on, I build in my project in Game Maker, doing a 2D top-down pixel art game similar to like the old Assassin's Creed multiplayer top-down games. You have clones of yourself and you find the other people. But been working on that for a couple years now, just learning the ropes of game dev. It's been a lot of fun though.
My name is Derek. I work as work in cybersecurity. Haven't done much game development, but working on a text-based adventure game. That's what I was thinking about. So I do a lot of writing right now.
My name is Aaron. I'm a maintenance technician. It's my day job. Just on the side, I'm making a top-down shooter, survival horror kind of game, just for practice, for fun. And yeah.
Hey, I'm Jared. By day, I work as a software developer for the government, and my project is called Thy Flesh Consumed. It's a single-player survival horror roguelite inspired by extraction shooters.
Hi, I'm Liam. I'm a programmer / mathematician / designer. I'm currently working on an Advance Wars ripoff. Let me know if you're interested in that. I'm doing some playtesting right now. Thank you.
My name's Madeline. I'm here for pizza. I'm married to him. I am a freelance artist, and I I was working on a game project, but it's kind of on hiatus right now because I'm working on other stuff. It was like a sort of hybrid 2D, 3D beat 'em up something.
Hey, I'm Gavin. I'm a computer science student at UVU, and I don't really have any experience with game dev at all, but pretty interested in it. So thanks for having me here.
Hey, I'm Isaac. I also a student at UVU, and I'm not working on anything.
All right. Just a reminder, we are streaming live on YouTube right now. All right, I'm going to do a quick presentation, and then we're going to have Ben's presentation. All right, so first things first. Sorry, wait, we're way into the meeting now. Sheesh. So this happened to me last month. Earlier this month. I want to tell you guys this. I received this innocuous-looking message saying, "Hey, could you play test my game?" Which is something I do all the time, like a couple dozen times, several dozen times per year. And I pulled the game, I downloaded it, I ran it. It produced some crash reports. It was definitely a Unity engine game. So I sent those back to the dev. And then like half an hour later, I got these notifications on Discord that the Utah game dev server had someone's account hacked, and they were spreading around a Trojan file. So I was like, huh. So I went back and looked at it. I was like, huh. And I went over and looked at my app data, and I found like a whole bunch of my passwords and browser data zipped up in a zip file with a advertising link pointing to a Telegram page run by French-speaking hackers. I was like, huh. So then I reinstalled Windows and reset all my account passwords, and it was I lost about a week of productivity. It was not fun. So please be careful on Discord. There are there's a very common game dev hack going around right now that is similar to this. The developers of Valheim actually lost their Discord server to it, as did the puppy games for the developers of Titan Attacks. Please be careful about messages being sent to you, even by people you know. Their account might have been hacked. Get on a call with them and talk to them, or at least try and run the file on a virtual machine or a sandbox if you can. I've also been encouraging people to start taking the extra effort to make their games as WebGL and demos as WebGL builds, which are generally better sandboxed by the web browser and less likely to cause these sorts of issues. Please be careful. There are people specifically targeting game developers going around right now. It's a very popular hack. All right. Was there anything else? Nope, that's it. All right, that is the end of my presentation. We're going to go ahead over to Ben. So, one more thing. Thank you to Kiln for. Oh, did you have a question? Yep, thank you. I should also point out that developers have been saying these around as files hosted on Discord, zip files, links to itch.io, links to Google Drive, links to Dropbox. They're very creative, and it seems like there's a lot of copycats doing the same. So whatever you do, just do be careful out there. I don't want to have to kick you off the Discord server because your account got hacked. All right, thank you. What else? That was it, actually. Oh yeah, Kiln. So one more thing, thanks to Kiln for letting us use the co-working space. Also, we were in the black for club dues last month. Thank you to everybody for donating. Please let me know. I've got a Venmo link on the Discord server in the expenses channel. So if you can, $3 helps pay for pizza. It helps pay for the meetup.com page, and generally helps the club run more smoothly. Let me know if you have any questions about that. I'll be happy to talk to you after the meeting. All right, we're going to have Ben come up now and do his presentation.
Thanks.
All right.
Nope. I don't have any slides with audio. All right, so I just have like 8 or 10 slides, and then we're going to switch over and I'm going to do some live shader building. So I'm Ben Cloward, and I'm a senior technical artist at Unity, and this is intro to creating real-time shaders. And I want to put an emphasis on intro because what I'm going to show today is pretty basic. Hopefully, boy, this is really loud. Maybe if I put it down here. Is that any better? No more feedback? Okay, cool. Hopefully this will be interesting. Those of you who have been working with shaders for a long time, maybe you won't learn anything new. Maybe this will be nap time. But I do want to kind of provide an introduction to this topic. So this is a little bit about who I am. These are some of the games that I've worked on over the years. Most recently, I worked for BioWare and worked on Anthem for 5 or 6 years and worked on Star Wars: The Old Republic for about 8 years. And then I worked on all these other games too. It's been a lot of fun. I've been a developer since 1999, so for about 25 years. Here are some other interesting facts about me. If you've used real-time shaders in either 3ds Max or Maya, chances are you've used my work. I contributed to the Uber shader for the Maya viewport. And I was also co-developer on the Shader Effects plugin, which we originally developed for 3ds Max, but then it was bought by Autodesk, and it's now like the main node-based shader editor for both Max and Maya. I'm also the product owner for ShaderGraph at Unity. So the tool that I'm going to be demoing to you guys today, I'm on the dev team and I help them to create that tool. Most importantly, I'm really passionate about shaders and I love helping people learn about how to create them. And I hope that comes across as we go over these things today. So this is what I'm going to talk about. I'm going to introduce some basic shader concepts, and then I have 3 live examples that I'm just going to kind of build interactively, and we'll see how that goes. I have distortion, flipbook, and environmental blend. These aren't things that you definitely need to know how to do, but they're kind of a vehicle for introducing various techniques. So I will be showing something cool that each of them do, but more the idea is that you learn general concepts than the specific things I'm going to be showing. And then at the end of the talk, I do have some links to places that you can go to find some more information. All right, so let's talk about some basics. What is a shader? What can a shader do? And I need to sneak in data types here. I guess those of you that are engineers are probably already familiar with this, but oftentimes I'll talk to artists and they don't know what that is. So I might just kind of gloss over that part. So a shader is a small program that runs on the GPU, and the result of a shader is usually a colored pixel. So the goal of a shader is to determine what color all the pixels are on the screen. And there are lots of there are a lot more details to it than that. I wonder if there's a way I can turn this down. Do you want to go ask them if they can turn it down a little bit? Just because it's getting a lot of feedback. All right, so yeah, shaders are in charge of creating the pixels on the screen and determining what colors they are. There is also transformations, so they figure out where the positions of all the vertices on the screen, and then they shade them in. There's a lot of technical stuff that I'm just going to kind of skip over. But you can do all kinds of things with a shader. I'm giving a talk at the Game Developers Conference in about a month where I'm going to be demonstrating a shader that creates a particle system. So it takes a set of billboards and makes them face the camera and then moves them around and generates smoke and waterfalls and all those kinds of things. So you can do all kinds of things with shaders. All right, let's see, I already talked about that. How's the audio now? No more ringing? Hopefully not. It's a little bit better. No, it's still ringing. Okay. So when shaders were first developed, a shader had to do everything from, wow, that's like a lot worse. Is that other microphone still on maybe? No? Okay. Okay, so I don't even remember where I was. So shaders now, at least the shaders that, man, this is so annoying. Is it okay if I just turn it off? Or do they need to have it for the broadcast? Yeah.
Sorry about that.
And the reason for that is because we want to make an object once and then put it anywhere in any level in any part of our game and have it still look correct. Before, when we used to mix these things together, when we used to bake ambient occlusion into our base color, when we used to make fake reflections with static cube maps and those kinds of things, you'd make an asset and it would look really good in your winter level with the snow and the ice, but then when you put it in your desert level, then it still looked wintry. Does that make sense? Because it had like the lighting information baked into it and that kind of thing. And so now what we're doing is the game engine exposes the shader parameters to allow you to define the surface properties in the shader, but then under the hood, the engine is actually doing the lighting properties for you. And so in the demos that I'm going to do today, we're going to be defining the surface properties for the object and then letting the engine do the rest. All right, so these are the 4 main data types that are most commonly used in shaders. Basically what this is like a float is like a box that you put data in. It's a floating point number. And then a vector 2 is like a box with 2 divisions and it can hold 2 numbers. A vector 3 has 3 of them in it, and then a vector 4 has 4 of them in it. Of an example of a vector 2 would be like your UV coordinates because they have a U and a V. A vector 3 would be like a normal vector or an RGB color. And a vector 4 would be like an RGB color with an alpha channel. So that's kind of the basics of data types. If you're using the material editor in Unreal to create shaders, it's kind of ambiguous what data types things are, and there's no way to know really. I don't know if any of you have run into that problem. That's one of the ways that I like Shader Graph better than Unity's material or than Unreal's material editor because it's more explicit about what data types there are, and I'll show you that when we get to that point. Okay, let's jump in and do some shader editing. And this is a part where I'm gonna not know what to do with the microphone here. So let me pull up my notes and we'll switch over to Unity. All right. So this first example that we're going to look at is UV distortion. So UV coordinates are kind of like Battleship. They help you determine like the U is horizontal and the V is vertical. And what you're really doing is figuring out a way of translating 3D space into 2D. The best way that I know of describing it is like you're unpeeling an orange. If you have an orange, that's a three-dimensional object. And if you unpeel it and flatten the peel out in one piece, that is like your UV coordinates of your orange. So then you can paint on your peel and then you wrap it around the orange again. And now you've got a two-dimensional painting on a three-dimensional object. I hope that is clear enough. What I've got here is a texture map that is a grid. And we use these to test out the UV coordinate. And what I want to show us how to do is just how to manipulate these UVs. So this node here is the, let's see if my mouse will work. Yeah, there we go. So this node here brings in the UV coordinates for the model. And we can manipulate these. So I'm just going to delete this here. And let's add something to our UV coordinates. So if I give myself a value here, and I'm going to use a float 2. Vector 2. So if I add something to my UVs, I can offset them. So right now I'm adding nothing because my values are 0. But if I take these and add like a 0.1, can you see how it moved down? If I add a 0.2, now moving down a tenth every time I add a little bit more. So adding to UV coordinates will move them. And I'm adding to the Y value here, but I can also add to the X. So I can move them horizontally as well. And instead of typing in a static number, if I take my time node and add it, now I have a scrolling texture. So adding to UV coordinates will scroll them. If I multiply the UV coordinates, it'll scale them. So multiplying scales and adding scrolls. All right, so the next thing that I can do is I can control my speed. So if I take my time here and add a multiply node, so now I've multiplied time by 2, so now it's going twice as fast. And if I want to slow it down, multiply it by 0.3, 0.5. So this value here allows me to control how fast it's scrolling now. All right, so right now I'm controlling the UV coordinates uniformly, or I'm moving them as a unit. But what if I want to move some more and some less? Well, I can do that with a texture map. So I'm going to add another node in here. That is a sample 2D node. So this node here is my texture map. And this, I'm going to bring in another texture here. So I'm going to have a very tired arm by the end of this show.
I keep switching.
Okay. All right, so I have another texture that I brought in here. I don't know if you can see that very well, but it's like a kind of a cloudy noise. And what I can do with this is every pixel in this texture has a slightly different value. So if I take this texture and I add it to my UV coordinate, now you can see my UVs have been scrambled up quite a bit. And that's because every value in the cloudy texture is pushing the UVs either up and down or side to side based on what its value is. And it's a value anywhere between 0 and 1. And so the UVs are being offset like a lot. And that's why it's so scrambled up. And so what I can do to bring this under control just a little bit is I can multiply the values coming out of this texture sample by a small number. And in this case, I'm going to multiply them by, let's say, like 0.03. And this will tone down the effect that we're getting a lot. So now you can see that you can make out the original texture now, but it's just kind of distorted a little bit. So the next thing that we want to do with this is actually animate the distortion. And so I can take what I had before, where I had my time here, and now I can, instead of scrolling this texture, I'm going to scroll this one. All right. So I'm going to add another UV coordinate node. And then I'm going to add my scrolling time. Actually, I need to add another vector 2 value. And see, I wrote down here in my notes what I was going to set these values to so it would look really nice. I'm going to set it to 0.34 and 0.23. All right, so we've got time multiplied by those two values. And then we're going to add that to our UV coordinates. And then we're going to pass those into our distortion texture. So now our distortion texture is scrolling and it looks like this, but now it's animated and contributing its distortion to our final result. So this is pretty good, and we could stop here, but there is one problem, and that is if we take a closer look at this, if you watch it for a few minutes, you can kind of make out the cycling pattern, right? Can you see the repetition? It's kind of, you can kind of make out the scrolling if you watch it long enough. And we want to get rid of that. And the way to do that, or one way to do that, is to kind of make our scrolling pattern a little bit more chaotic. And the way that I'm going to do that is by duplicating these nodes here. Let's see here. Copy these and paste them down here. There's paste. You guys see paste in this menu? Copy, paste. Hey, there we go. Okay. So, and then, so this is also, this unit is also scrolling its texture here, but now I can give it different values so that it's scrolling in a different direction. So I'm going to add, I'm going to make this one 0.13 and 0.26. So if we look at this preview here, you can see this one's kind of scrolling in a vertical direction. And then I can take the results of both of these scrolling textures and add them together. So they're scrolling at different speeds and in different directions. And our result is kind of like this interference pattern. And because they're going at different rates and in different directions, it creates something that's a lot more chaotic. And so what that'll do for us is break up our repetition so that we no longer have that pattern that you saw where it was like, it's probably less likely that you can see a visible pattern. That's kind of the point. All right, are there any questions before we move on to the next example? Yeah. My point with this example was showing how to manipulate UV coordinates. You can move them around, you can scale them, you can distort them. And the texture that I'm using here is not really significant. I could use stripes or polka dots or whatever, but I think it's kind of the most, like the easiest to see the distortion when you have these grid lines. And the color kind of helps you see like, oh, if you have this map to a three-dimensional object, it's harder to tell like, where are my UV, where's the origin of my UV coordinates? In this case, it's in the upper left, but if it's on a 3D model, like you may not be able to tell. And so the colors here kind of help you orient yourself when you're seeing the texture applied to a mesh. Yeah, yeah. I'm not doing anything here to make sure that that doesn't happen. So it very well could happen. If the texture wraps around, I guess you can kind of see that happening here. Like it's sampling the the pixels that are going off of one side are wrapping around to the other side. And there's a setting on the texture actually that you can tell it like clamp it to the edge or wrap it around if it repeats, that kind of thing. Okay, pretty cool. If any of you are asleep, I hope that I can wake you up now because this is the part of the talk where we talk about explosion. So let's close this down. And I'll just throw that away. We'll switch to the second example here. All right, so our goal here is to create an explosion. And if you do a simulation that's using like fluid dynamics, it's a very expensive process. And so a really cheap hack that most of you are probably aware of is rendering out the explosion to frames and creating a flipbook animation. And most engines have a node built into their shader editor that does this flipbook animation. But in order to, I can just take that for right now. In order to help us understand what's happening under the hood, this next example, I'm going to kind of break it down and show you how the math works inside a flipbook. What we're going to do this time, we're also going to be manipulating UV coordinates here. But what we want to do is, instead of just showing the entire texture like this, we want to edit our UV coordinates so that it jumps from one frame to the next. And we need it to show the first row and then jump back to the beginning and show the second row and go along and then jump down and show the third row, etc. And so I'm going to show you how the math works in a shader to make that happen. Yeah, question. Yeah, so an effects artist will use Houdini, and Houdini has like fluid dynamic simulations, and they would do it there, or they would like create a practical effect and film it, or they would use an asset library where somebody else has done that. There are a lot of different methods for doing that, yeah. This particular texture was taken from a blog on Unity's website where they have maybe 20 or 30 of these available for free. So they have like smoke and fire and explosions, and they're just available for anybody to use. So I grabbed it and now I'm using it for this example. All right. Thank you so much, Thomas. Okay, so right now we just have our UV coordinates and they're plugged into our texture. And the first thing that we want to do is scale our texture so that we're only showing one frame of the animation. And in order to do that, we need to know how many rows and columns we have. And in this case, I have 5 rows and 5 columns. So I'm going to add a vector2 node here. And I'm going to say my texture has 5 rows and 5 columns. And then I'm going to take the reciprocal of that value. A reciprocal is the same thing as 1 divided by the number. So in this case, I'm doing 1 divided by 5. And then I'm going to multiply my UV coordinates by that value. So now my UV coordinates are just showing 1 frame of my animation. All right. The next thing that I need to do is introduce some animation or some motion to it. And so I'm going to add a time node again. And we're going to multiply time by a value that I can use to control the speed. And in this case, this value is going to represent frames per second. So to start with, I'm just going to give it a value of 4. So we're going to make our explosion go kind of slow at the beginning. So we're making our time go 4 frames a second. And then I'm going to add the time to my UV coordinates. And now we have something that's just scrolling diagonally. And this is not quite what we want. We want it to jump from one frame to the next. And so right now our time is just moving continuously. But what we actually want to do is have the time jump. And in order to do that, we need to add a floor node. And what floor is going to do is, as our time increments, it's going to round it down to the nearest whole number. So I'm going to take my time value multiplied by my speed. And let me just double check this. Yeah, so I need to add a floor node right here. And this is going to round our time down. There we go. All right, so now you can see instead of scrolling continuously, our time is actually jumping because I floored it, which means it's rounding it down. And so now what it's doing is it's showing all of the frames on the diagonal. And that's not quite what we want. We want it to go across and then jump down and then go across and then jump down, right? And so the next thing that I need to do is I need to take my speed value here and split it so that I'm treating the horizontal movement differently from the vertical movement. I only want it to jump vertically every time it gets to the end of a row. And so the way that I can do that I'm going to use this combine node here. So the horizontal movement is going to continue as it is. But with the vertical movement, I want to divide it by the number of rows there are. So it's only going to be jumping every 5th time. So this has my number of rows and columns. So I'm going to split this out. I'm going to use a swizzle node here. This allows me to just take one of the 2 components. So here I have an X and a Y, and I'm just grabbing the X, and I'm going to divide it by that. Then I'll plug that in here, and I'll plug that in here. So now what it's doing is it's going across, and every time it gets to the end of a row, then it's going to jump. But as you can see, it's a little bit out of phase, and I need to add just a few more adjustments. If I were doing this in Unreal, at this point, it would be perfect. But in Unity, the UV coordinates are inverted. And so I need to invert things just a little bit in order to get the results that I'm looking for. And so I'm going to add a flip node. Flip. So here I'm passing my UV coordinates into flip. And I'm going to invert the Y or the V coordinate there. And then right at the end here, before I sample the texture, I'm going to invert it again. All right, and now I have my explosion, except it's only going 4 frames a second. And it's really supposed to go 24 frames a second, so I'll just increase that. And boom, we have explosion. This is the part where you clap. No, just kidding. Yeah, thank you. Thank you. All right, so there's a little bit of math involved, and we're doing some manipulation, but we're able to set these UV coordinates so they correctly move from one frame to the next, and go along horizontally, and then move down to the next row and the next row, et cetera. Yeah, you have a question? Yeah, I don't know if this texture has an alpha channel, but usually something like this would have an alpha channel that would determine like this is where it's opaque and this is where it's transparent. I kind of skipped that in this example because it's trying to stay more basic, but yes, absolutely. Or you could make it additive, the same kind of thing. All right. Let me talk through this a little bit. So, whoops. So this next example is environmental blending. And this is kind of born out of the necessity to make fewer assets. So let me explain that just a little bit. If you're making a game that has a snow level, a desert level, and a jungle level, and you go to your environment artist and you say, like, I want jungle rocks with moss on them, and I want snowy rocks, and I want desert rocks with sand on them, he's going to be like, man, that's a lot of rocks. Can we just make like rocks with nothing and then apply the things to them? And so what I'm going to show you how to do now is that effect. Not only that, but something that is really popular to do is to make yourself like 5 rocks and then use them everywhere. And the reason that you can use them everywhere is you make the rock in such a way that you can randomly rotate it and it looks good from any angle. And then you create the shader in such a way that no matter how you rotate this rock, your stuff, your environment effect is always going to be applied to the top of it. So I'm going to show you how to create that effect. How are you doing, Thomas? All right. All right, so right now we've got our rock here, and we're just using a color texture and a normal map. So you can see the normal map is kind of creating these kind of lumpy, wrinkly shapes in the rock. And then we've got our nice color texture there. And we want to bring in our textures that represent our moss. And this is our environment effect. So I'm going to create some sample texture 2D nodes. This will be our moss color. And then I'll create another one. And this is going to be our moss normal map. And a normal map controls kind of the shape of the surface. And I need to set my texture here to normal so that it knows to treat it as a normal. And then I'm going to bring in my UV coordinates for sampling. And I want the moss to look a little bit smaller, a little bit more detailed. And so I'm going to multiply the UV coordinates by 2 so that right now the moss is just tiled one time, but by multiplying my UV coordinates by 2 there, now I'm tiling my moss twice, which will make it a little bit more detailed. Okay, so I have my rock textures here, and I have my moss textures over here, and I can plug in my moss textures. And now instead of looking like a rock, it just looks like a round sphere ball of moss. So I need a way of blending these together. And one way that you can blend them together is with a lerp node. Lerp is short for linear interpolate. And so I'm going to add a lerp node. And I'm going to plug my rock texture into A. And I'm going to plug my moss texture into B. And then this T value here is the value that I can use for, it's a mask. I can use it to determine where is the moss going to show and where is the rock going to show. So let me plug this into my base color here. And what this is going to give me is all rock because my T value is 0. Wherever it's 0, it's going to show A. And wherever it's 1, it's going to show B. Right? So if I give it a value of 1, now it's showing the moss. And if I give it a value of 0, it'll show the rock. Let me add just a float here. And if I give it a value of 0.5, now it's like a transparent moss. It's like half rock, half moss. Can you see how it's blended and it's like half and half? Well, that's not really the way moss behaves. Moss isn't transparent. And so we need to create a mask to apply this moss only to the top portion of the rock. And the way that we can do that is with a normal vector node. So this brings in a normal vector, which kind of defines the direction that the surface is facing. So the colors represent, instead of color, they represent direction. So I have X, Y, and Z values here. And I happen to know that the Y value represents if it's facing up or down. So if I come in here, I'm just going to add a preview node here temporarily so you can see what it's doing. So I've split out this normal vector node and I'm giving it the Y and it's showing like the up direction. So I have a white mask where everything that's pointing up is white and everything that's pointing down, actually it's 1 and -1 in this case. So I can use this as my mask. So I'm going to grab this value and plug it in over here for my lerp. And now you can see the moss is getting applied to the top of the rock and not the bottom. Okay? Now I need to adjust this mask a little bit. So I'm going to add a couple of nodes to kind of get it into the shape that I want. I want to add 0.75 to it. And then I'm going to add a saturate. And what saturate does is it clamps it between 0 and 1. So this, can you see how my sphere here is kind of getting blue at the bottom? That's because I'm passing my lerp node a -1 value, and it's actually pushing it past the rock color in the opposite direction of the moss color. That's kind of a weird concept, but that's what happens when you give a lerp node a negative value. It actually goes in the opposite direction that you want. And so I'm adding this saturate node here, which will ensure that my values stay between 0 and 1. If it gets to 0 and wants to go below, it's going to stop it. And if it gets up to 1 and wants to go above, it's going to stop it. So that's what saturate does. And then I'm going to add a power. And this is going to raise my value to the power of whatever number I type in here. And in this case, I'm going to raise it to a value of 6. And the purpose of that is to increase the contrast. And so if we take a look here at the saturate, this is what the power is doing. So here's before and then here's after. And so all of these nodes here are just for the purpose of like, I started out with the normal Y, and it was like a really smooth gradient between the top and the bottom. And now I'm just kind of adjusting them and finessing them so I get something that works more for what I'm trying to do. Okay, so I'm going to plug this value into my lerp now. Now you can see I've got my moss on the top of my rock. And not only that, but I can rotate my rock all around and the moss is staying on the top. And I need to do the same thing with my normal map. So I'm just going to come over here, get this node out of the way. I'm going to add another lerp node. And I'm going to blend between my rock normal here and my moss normal. And we're going to use that same mask value that we created over here. And I'm going to plug this into the normal slot. All right, there we go. So we could stop here, but I feel like it's a little bit too smooth. Like it's not actually conforming to the shape of the rock. And that's because the rock is using this normal map here, and I'm not actually taking into consideration the way the normal map is altering the shape in order to create my mask. And so what I want to actually do is take this normal map and use it for the shape of the mask instead of my vertex, my normal vector here. And so in order to do that, right now my normal map is in tangent space, and I need to convert it to world space. So I'm going to add a transform node. And on my transform node, I'm going to say, I have a normal that's in tangent space, and I need it to be in world space, and my type is a normal. So now, instead of using the vertex normal, I'm actually using the pixel normal. And now you can see that the moss is actually going into the cracks and crevices because now I can see that normal map. I'm using the normal map for the mask. And no matter how I rotate my rock around, that moss is always going to stay on the top. And if I expose the slots for my textures, if I put my rock in my snowy level, I can swap out the textures and put snow on it. And if I put it in my desert level, I can swap out the textures and put sand on it. And now, you know, I've only made like 5 different rocks, but just with material swaps, I'm able to get like infinite variety and make these same assets blend in to whatever environment I put them in. All right, so any questions on that? Oh yeah, lots of questions. Thanks, Thomas. Yeah, right here. Right, so I'm just using the normal right now, but I would have to give it, instead of a normal, I would have to give it the vector of the angle that it's coming in and use a rotation node to rotate the vector and then use that as the projection. Uh-huh. Good question. I think I actually, if I didn't delete it, I think I might have it on here. So let me look. If you use Unity, I have a package that has all of the data like packaged up that I can give it to. I could do that as well. Yeah. Okay. Right. Correct. So since this is being applied from the top down, if I wanted to take this further, I could probably use the world space XZ coordinates to do my texture projection for the moss. And that would both cover up the singularity and do a better projection for the moss. Yeah. Mm-hmm. Okay. Who else had a question? Nobody else? All right. Yeah. Good question. Saturate is exactly the same as a clamp between 0 and 1, except if you explicitly tell the hardware to saturate it, it can do that for free without using any assembly instructions. Usually the compiler will figure out how to get that operation done without using any math. And usually, like if the compiler is good, if it knows what it's doing, if you give it a clamp with a value of 0 and 1, it'll convert it to a saturate, like for you under the hood. But I'm kind of old school, and I'm just kind of in that mode where I'm thinking like, oh, I want this to be as efficient as it can be, so I'll use a saturate. Yeah, great. Yes, any values that are static will be pre-computed and stored as a constant. The compiler does that, hopefully. And if not, you can do it yourself, like in your head. Like if it's not running as fast as you want it to, you can try all kinds of things where you like pre-compute things. But yeah, you don't want to try to give it extra math to do that isn't necessary. So yeah, that's a good point. Any other questions? No? Okay. I just have a couple more slides, and then we can finish up. This has been really fun, you guys. Thanks for letting me come up here and ramble about shaders. Okay, so if I piqued your interest and you're really excited about this stuff, here's a couple of things that you can do to like continue your learning. You can take a look at games. That idea for like the environmental blending where you apply stuff to the top of an object, the one that I just showed, I got that idea from Skyrim. I was like, oh, that's really cool, because they were doing that with snow on top of their rocks. So that's one example, but just like take a look and see what other games are doing. Thomas like has been using shaders recently. In his game, he made like a vortex effect. So if you want to give yourself some exercises to try out, just like find other games and be like, oh, I want to try that, and then just try to figure out how to do it. Grab a book. There's a lot of videos on YouTube for learning shaders, including my channel, and I'll show that in a second. You can download Unreal and Unity for free, and I'm sure you guys already know that, and then just jump in and do it. I get asked this a lot, and so I put together a list of books on my website for how to learn. These books are the ones that I learned from, and I started learning shaders maybe like 20 years ago. And so some of these books are quite old, but the information is still like completely valid. Even though the books are old, it's still like applicable information. Like the basic principles of computer graphics don't really change. And then if you're interested, here is a link for my YouTube channel. I publish videos every week explaining how to do all kinds of things with shaders, starting with like really basic principles like I showed today up to like a lot more advanced stuff. So yeah, that's my YouTube channel. And yeah, that's my talk. So thanks for listening and thanks for your great questions. And if you want to email me, that's my email address and my Twitter handle. And I'm on the club Discord as well.
All right, thank you very much, Ben. I do think you're the most famous person who's given a talk here, at least for the club. I don't know about Kiln. All right, thanks everybody for coming. We're going to move over to onto the demo part of the meetup. If you have a demo, please go ahead and set it up. Feel free to use any of the tables in here for that. The room's arranged a little differently than it usually is. we'll try and get you a copy of the video so you can post on your YouTube channel if you want to. And I'm going to let anybody who wants to use the screen up here, but you have to call dibs on it first. Okay, you got it. All right, thank you all for coming. Please wrap up and start getting things together, getting things out of here at 7:55. We have to be out by 8 sharp. Okay, thank you all for coming.